Last week we talked about solving equations that had fractions. We also talked about solving equations where we had variables on both sides. We talked about having to distribute in our equations. Today we're going to talk about fractions that involve decimals. So I want you to think about the properties of fractions when we're solving equations. When we solved equations, we multiplied the entire equation by its least common denominator. Do you remember that? Least common denominator. We are going to do something similar when we have decimals. We are going to multiply essentially by the least common denominator, but we need to kind of think about how we figure out what that is. So in this problem right here, I have 2/10 x plus 24 hundredths equals 8/100 x plus 72 hundredths. So I am looking at this term right here, and I have one decimal spot in that term. In this term right here, I've got two decimal spots. In this term right here, I've got two decimal spots. And in this term right here, I've got two decimal spots. If I have 3/10 and I multiply that by 10, so if I have 3/10 and I multiply that by 10, what do I get? 3. Okay? I get 3. Because I have to move this one spot. When I multiply by 10, I'm going to move the decimal once. What happens if I've got 3/10 and I multiply that times 100? What do I have to do? I make it 30. So I move my decimal twice. And I don't have anything here, so I have to put a 0. So 3/10 times 100 gives me 30. Now, just like if I had 1/2 x plus 3/4, I would have to multiply all of this by 4, because 4 is my least common denominator. That means 2 goes into 4 and 4 goes into 4. When I am dealing with decimals, I have to do something very, very similar. I have one decimal spot and I have two decimal spots. When I have one decimal spot, I've got to multiply by 10. When I have two decimal spots, I've got to multiply by 100. Does 10 go into 100? Yes. So 100 becomes our least common denominator because I've got to take care of all the decimals. If I multiply this by 10, I only move this decimal one spot, and what do I still have? A decimal. Okay, so I haven't solved anything. So in this example right here, in this problem, what we're going to do is we're going to multiply everything by 10. No, we're not going to multiply everything by 10. We're going to multiply everything by what? 100. We're multiplying everything by 100 because we have two decimal spaces on some of our numbers. The multiplying by 100 deals with this one that just has one decimal spot. Okay? Yes?
Can you actually just subtract the decimals as they are?
Yes, you can. Yes, that's not a problem at all. If you don't want to eliminate the decimals, yes. You can just work with the decimals. Absolutely. Okay, so the question was, can I just work with the decimals? Can I subtract 8/100 from both sides and then subtract 24/100 from both sides and just work with the decimals? And you absolutely can. If you're comfortable working with decimals, you're going to get the same answer. Just like when we dealt with fractions, instead of multiplying by the LCD, we could have just changed everything into a common denominator, subtracted, and we could have done it the same way. So absolutely. Some students think this is an easier way, so it's really kind of up to you on what you think. Okay, so we're going to multiply everything by 100. So I've got 100, and I am multiplying that times 2/10 x. Then I've got 100, and I am multiplying that times 24 hundredths. That equals 100 times 8/100 x plus 100 times 72/100. Okay, now 100 times 0.2. I've got to move that decimal spot twice. Okay, and I don't really have room here, so what do I have to stick right there? 0. So 2/10 x, once I multiply it times 100, becomes 20x. 24 hundredths, once I multiply it by 100, I move that decimal spot 2 spots, and I get 24. Here I've got 100 times 8/100 x. I move that decimal spot 2 places, and I get 8x. Here I've got 100 times 72/100. Move that decimal 2 spots, and I get 72/100. Okay? Does that look like a problem we have solved before? Yes, ma'am.
I was going to ask, so the next test is on September 27th. Have you put that on Canvas?
Yes. Yes. Okay. Okay, so 20x plus 24 equals 8x plus 72. We know how to solve this. I'm going to subtract 8x from both sides. Okay, so I'm left with 12x plus 24 equals 72. I subtract 24 from both sides. So I am left with 12x equals 48. Now, if we have forgotten how to subtract, we are subtracting 24, not 48. 72 minus 24. Okay? We remember back probably from 3rd, 4th, or 5th grade. We can't do 2 minus 4. I have to borrow from the 7. My 7 becomes 6. My 2 becomes 12. That's how I get my 48. Okay? Now I divide both sides by 12. What's my final answer? 4. Okay? So my final answer to this is 4. Okay. Can I go to the next one? Okay. Now, before I start working with this one, I want us to think about this problem down here. -2 times 3 times 6. I want us to think about that. How do I solve -2 times 3 times 6? How do I solve that? Or how do I evaluate this? Evaluate's the better term. What do I do? Good. I'm going to multiply. Okay, so -2 times 3 is what? It's -6. Okay? Once I have that -6, once I've done -2 times 3 and I've gotten my -6, do I do anything else with that -2 and that 3? No, I've dealt with it. It's done. It's in the past. Now I deal with -6 times 6. That is -36. Okay? Now, let's do something slightly different. What if I had -2 times 3 times x plus 1? So instead of the 6, all I've done is replace that with x plus 1. Once I deal with the -2 times 3 and got -6, what do I distribute to the x plus 1? I distribute negative 6. Okay? I don't distribute the negative 2 and the 3 because I have dealt with the negative 2 times 3 and I've turned it into negative 6. So the only thing I distribute there is the negative 6. We are going to use that concept with the above problem because this type of problem right here, students get confused because of that. Now, I've got 1200ths x, and 1200ths x gives me 2 decimal spots. Then I have 1/10, and that 1/10 is being multiplied times 7,000 minus x. Now, if we wanted to just deal with the decimals, we could. We absolutely could. But we're going to eliminate the decimals and see if that makes it easier to deal with. So, do I need to multiply everything by 10 or do I need to multiply everything by 100? 100. I need to multiply everything by 100 because I have 1200ths. Now, the fact that I've got this 1/10 right here, that's going to be dealt with fine because I'm multiplying by 100 because 10 goes into 100. Okay, so I am multiplying everything times 100. Okay, so I'm going to erase all this. So I have 100 times 1200ths x. Then I have 100 times 1/10 times 7,000 minus x. Okay? I'm only multiplying the 0.1 times 100 because of the same principle that I used here. Once I've dealt with the negative 2 and the positive 3, I've got negative 6, and then I just multiply by 6. So I just need to multiply this 100 by this 1/10, and then I've dealt with this entire term. That is where students make mistakes. Right there. That's where they make mistakes. So put a little star there to go back to it. Then I have 790 times 100. Okay? 100 times 1200ths x leaves me with 12x. When I multiply 100 times 1/10, what do I get? 10. Good. Then I've dealt with this. So now I have 10 times 7,000 minus x. So don't feel like you've got to multiply the 7,000 minus x by 100 because you are when you multiply it by 10 because you've already dealt with this right here. So you're distributing 100 times 1/10 when you distribute the 10. Just like I dealt with the negative 2 and the 3 to get the negative 6. Okay? Then 790 times 100, I'm going to move the decimal space twice, so I'm going to add 2 zeros to that, and I'm going to have 79,000. Okay? Now at this point, students tend to do okay. So I end up with 12x plus 70,000 minus 10x equals 79,000. Okay, now I subtract 70,000 from both sides. Whoops. And I should have done this first. So 12x and minus 10x. What does that give me? 2x equals, what does 2x equal? 9,000. Okay? Now I divide both sides by 2, and I get x equals 4,500. Now, just as a review, in case we've forgotten how to divide, the 9,000 goes in the box. The 2 goes on the outside. 2 goes into 9 4 times. 4 times 2 is 8. Then I bring down the 1. I bring down the 0. 2 goes into 10 5 times. 5 times 2 is 10. Okay? And I'm left with 4,500. Okay? So my final answer here is x equals 4,500. Okay? Can I go to the next slide? Nope, no, you're good. You're good. I'll just kind of start talking. So think about equations with decimals the same way that you think about equations with fractions. You're going to multiply by something to get rid of all your decimal spots. Or you can. You don't have to. You can. Now, we're going to move into solving formulas for a specific variable. This happens a lot when we are working with our science classes, chemistry, physics, biology. It happens a lot that you have to solve for a specific variable. It also happens when we graph lines. So one of the things that you probably remember from high school is y equals mx plus b. Y equals mx plus b. Y equals mx plus b is how you graph a line. And we will do that, but it'll be towards the end of the semester. But we will graph lines. Here, I am given a linear equation, but it is in standard form. We can't do a lot with a linear equation in standard form, so we need to put it in y equals mx plus b form before we can graph it. And the way that we do that is we solve for y. Now, I have an x value and I have a y value. So I can't combine as many like terms as I've been used to when I've been dealing with equations. So a lot of times I can't combine the terms, I just have to still deal with all the properties. So the way that I'm going to solve this one for y is I am going to subtract 2x from both sides. When I subtract 2x from both sides, okay, I can't combine the 7 and the 2x, or the 7 and the minus 2x. So I just have to write it down as negative 2x plus 7. Now, students very often will drop their negative sign. Very, very often they will drop their negative sign. So here, you've got to make sure that negative stays with the 5. Make sure that negative stays with the 5. So we have negative 5y equals negative 2x plus 7. Now I divide everything by negative 5. When I do that, negative 2 divided by negative 5 is positive 2/5. Why is it positive? Good. Negative divided by a negative is a positive. Then I've got positive 7 and negative 5. That is negative. Okay? So y equals 2/5 x minus 7/5. So that is what I'm looking for right here when I solve for y. Yes? That will be the slope when we start graphing. Yes, ma'am. Can we do another one? Okay. Do you recognize this formula? It is the formula for perimeter. I had somebody last class say power, and I was like, don't think physics, think geometry. Okay, so this goes with our geometry. This is a perimeter of a rectangle. So perimeter equals 2 times the length plus 2 times the width. What we are going to do is we are going to solve for W. That's what we're going to do. We're going to solve for W. Okay? So, I am going to, the first thing that I'm going to do is I'm going to subtract 2L from both sides because it's my W that I want to get isolated. Okay? So, minus 2L minus 2L. Are P and 2L like terms? They are not. So I cannot combine them. So I have to write P minus 2L, and that equals 2W. What do I need to do next to get W by itself? Good. Divide by 2. Now, I would stop here. This is a reasonable answer. This is reasonable right here. However, some of you will say to me, Alicia, can't I cancel the 2's? I've got a 2 on the top and I've got a 2 on the bottom. Why can't I cancel the 2's? You can cancel the 2's. However, my 2 in this denominator right here, it belongs to both the P and the minus 2L. So you've got to give that 2 to the P. Then you've got minus 2L over 2. And at this point, you can cancel these. Okay? But you can't cancel it when it's written like this. So that's why I tell students to stop here. You don't have to stop here. You can go to this next step. So either one of these answers is correct. So P over 2 minus L equals W. That is a 100% acceptable answer also. Okay? Either one. Can I go to the next screen? Okay. We're going to deal with that negative 2 times 3 times 6 concept again. That's going to come up again in this one right here. What's happening between the 1/2, the B, and the H? What's happening there?
It's 1/2 times base times height. Is how you find the triangle.
It is. It is the area of a triangle. You're multiplying it all. You're absolutely right. We're multiplying all of those. So this idea that we've dealt with already today is going to come up again. So I've got a fraction. How do I get rid of the fraction? You're good. What's my LCD? 2. Okay? And we've been dealing with such big numbers, you think that 2 just can't be enough. But it is. You've only got a denominator of 2. So I'm going to do 2 times A. Then I've got 2 times 1/2 B times H. All of this is being multiplied together, so we follow this idea right here. 2 over 1 times 1/2. We've gotten rid of our fraction. So now we're left with 2A equals base times height. We are solving for H, so now I divide by B. So 2A over B equals H. Okay. Can I move to the next one? Okay. This is the type of problem that gives us the most headache. Okay? When we deal with inverse operations in 144, this will be another situation where it gives us a little bit of a headache. Now, here, I'm solving for P. Many students look at that and say, oh, Alicia, that's easy. I'm just going to subtract this from both sides, and I'm going to have A minus PRT equals P. I'm done. You're not done. Because I have solved for P, but what do I have right here? I have another P. So that's not going to work. Okay? This is incorrect. So the first thing that I have to do here, and this is what students forget. They're not sure what to do. Okay? If I had 3, let's not do 3. Let's do K times 1 plus R. Okay? K times 1 plus R. And I distributed that. Okay, what would I be left with if I distributed this right here? K times 1 is, what's K times R? Okay, now, if I have 2x plus 4, can I pull a 2 out of that and get x plus 2? What is that called that I just did right there? Anybody remember what that's called? I factored. I factored out a 2 because that was common in the 2x and it was common in the 4. Here, I distributed the k. Here, I factored out the 2. Now, let's say I have something like p plus PR. Can I factor out a p the same way I factored out a 2? Yes. So then I'm left with p times 1 plus r. So that's what I have to do up here, is I have to factor out a p. So I have a equals p. P times what gives me p? Good. P times what gives me PRT? RT. Okay. Now I can divide both sides. And I have isolated my P. So my answer to this is A over 1 plus RT equals P. Okay? And that is my final answer for this one, for solving for P.